Hello everyone, welcome back to my YouTube channel. I am Astha of first semester pursuing my computer science and engineering from Sri Venkateswara College, Bengaluru. In this video, we will discuss about some topics of mathematics. The subject code is BMATS 101. So let's get started. So in today's video, we will discuss about the applications of polar coordinates. In this video, we will study about what are polar curves, polar coordinates, the relationship between the Cartesian coordinates and the polar coordinates, and lastly, the applications of polar coordinates. So, to understand what are polar coordinates, we must first know what are polar curves. A polar curve is simply the resulting graph of a polar equation defined by r and theta. We use the polar grids or polar planes to plot the polar curve, and this graph is defined by all sets of r and theta that satisfy the following given polar equation, that is r is equal to f of theta, where f is function. When each point on a plane of a two-dimensional coordinate system is decided by a distance from a reference point and an angle is taken from a reference direction, it is known as polar coordinate system. Here, instead of using the points as x and y, we express it in terms of r and theta. So now let's look into what are polar coordinates. In this, the initial reference is chosen by spotting a point O in the plane which is known as the pole, and a line OL is drawn through O which is known as the initial line. If P is any point in the plane and we join the points O and P, the result an angle is formed at O. The length of OP is denoted by R and it is known as the radius vector of the point P. And the angle which is formed, that is angle LOP, that is denoted by theta and it is measured in anti-clockwise direction and it is known as vectorial angle. The pair of r and theta is represented by P and it is known as the polar coordinates of the point P. It is evident that r is positive and theta lies between 0 and 2 pi according to the position of the point P in the four quadrants. So here O is the pole, line OL is known as the initial line, P is a random point in the curve. When we join OP, an angle is formed, angle LOP, which is known as the vectorial angle, and OP is known as the radius vector, hence it is represented by alphabet R. So now let's see the relationship between Cartesian coordinates and the polar coordinates. Let x, y and r theta respectively represent the Cartesian and the polar coordinates of any point P in the plane where the origin O is taken as the pole and the x-axis is taken as the initial line. So here we have OQ is equal to x, PQ or QP is equal to Y and OP is equal to R. Also from the right angle triangle OQP, we have cos theta which is equal to base by hypotenuse, that is equal to OQ by OP, which is x by R. So this we can rewrite as x is equal to R cos theta, and we take this equation 1. Next, sine theta, which is equal to the perpendicular by hypotenuse, that is QP by OP, which is equal to Y by R. So this equation we can rewrite as Y is equal to R sine theta. And this we take as equation number 2. So by squaring and adding 1 and 2, we get x square plus y square is equal to r square cos square theta plus sine square theta. So when we take cos square theta plus sin square theta, we know that this is equal to 1. So this equals to r square into 1, which is finally equal to r square. Therefore, r is equal to root under x square plus y square. Also dividing equation number 2 by equation number 1, we get r sin theta divided by r cos theta is equal to y by x. We know that sin theta divided by cos theta gives us tan theta. Therefore, tan theta is equal to y by x. But here we have to establish a relationship between the polar coordinates and the Cartesian coordinates. So we will find theta. Theta is equal to tan inverse y by x, and we take this as equation number 4. Equation number 1 and equation number 2, that is x is equal to r cos theta and y is equal to r sin theta, that represents the Cartesian coordinates in terms of polar coordinates. Whereas equation number 3, that is r is equal to root under x square plus y square, and equation number 4, that is theta is equal to tan inverse y by x. These represents the polar coordinates in terms of the Cartesian coordinates. It is evident that r is a function of theta. That means r depends on theta, and the equation in the form of r is equal to f of theta, that is known as the equation of the curve in the polar form. So now let's look into some applications of polar coordinates. Polar coordinates are used in various mathematical and scientific applications. Some examples are: first, physics. Polar coordinates are used to describe the position and motion of objects in a circular or rotational motion, such as in the study of planetary orbits, pendulum motion, and rotational dynamics. Second, engineering. Polar coordinates are used in engineering applications such as antenna design, signal processing, and control system, where circular or radial symmetry is present. Mathematics. Polar coordinates are used in complex analysis, calculus, and geometry to simplify the representation and analysis of functions and shapes with circular or radial symmetry. Cartography. In cartography, polar coordinates can be used to represent and analyze data on maps that have a circular or radial layout, such as polar maps. Fifth, art and design. Polar coordinates are used in computer graphics and design to create circular or radial pattern, as well as in artistic representations of symmetry and rotational shapes. Another important application of polar coordinates is position and navigation. In navigation, polar coordinates are used to describe the location of a point on the surface of the Earth. The polar radius represents the distance from a reference point, such as the center of the Earth, and the polar angle represents the direction from that reference point. Aircraft uses a slightly modified version of the polar coordinates for navigation. In this system, the 0-degree ray is generally called the heading 360, and the angles continue in a clockwise direction rather than counterclockwise or anticlockwise as in the mathematical system. Heading 360 corresponds to the magnetic north, while heading 90, 180, and 270 corresponds to the magnetic east, south, and west direction respectively. GPS is the best example of very successful application of spherical coordinates. So with this, we come to an end of our video. I hope that you guys like this video. For such more videos, please subscribe to my channel. Thank you.